Hello, so let's talk about the differentiation of quotients, otherwise known as the quotient rule. Again, without going into the explicit arguments, we can say that if f of x equals something like we'll just say u of x to use prime notation over v of x. Basically, what the quotient rule states is that well, what it allows us to do is to differentiate rational functions, where a rational function would be in this form, where u of x over v of x, where u of x and v of x are both functions in themselves. And so if this is the case, if we have some function f of x that equals all of this, then the derivative, again to use prime notation, would be something like f prime of x equals, and you would basically just want to take your v and multiply it by u prime, so the derivative of u, and then you're going to subtract, and you're going to take your u, your function u, and you're going to multiply that by the derivative of your function v, and all of that is going to be over v squared. Yeah, I mean, the trick is part of this really, when differentiating quotients. It's just sometimes you might be given tricky functions, and you might have to use inspection to kind of just separate things neatly. But as a whole, it's quite straightforward. And to kind of show that, let's just work on an example. Let's just say, I don't know. Let's just say we're given something like say we're given something like f of x equals, do something simple but explicit enough. Let's say like in detailed enough, like x over 2x plus 5. Right, like so here we have our u, which is just x, and here's our v, our function v, which is 2x plus 5, right? And sometimes you'll actually see this just written like this, uv, right? We don't, where again, they're both functions of x, but nevertheless. So in applying the quotients rule, really, we're just following this formula where we would just say, well, f prime of x is then going to equal, well, what's v? Well, v is 2x plus 5, right? So we're just going to plug that in, basically. U is x, well, what's the derivative of x? It's just 1. And we're going to subtract our u, which we already know is x. And then we've got our v prime. Well, what's the derivative of 2x plus 5? Well, 5 is a constant, so it just cancels. And then you have your 2x, and the derivative of 2x is just going to be 2. And then, of course, all of that is going to be over our function v, and we're going to square it. So we've got 2x plus 5, and all of that is going to be squared. At this point, I suppose it's just about cleaning up the algebra, and which is simple enough. We're going to have, well, this is going to equal 2x, whoops, pen tool, 2x plus 5, keep that in brackets, right? Because 2x plus 5 times 1 is just 2x plus 5. And then we're going to have minus 2x. And all of that is going to be over our v squared, which is just going to be 2x plus 5 squared, as we've already got it here. And so we can simplify this a bit, can't we? We can take, 2x is positive here on the left, and we're subtracting 2x, so that will cancel. This will cancel, and there's not a lot else that we can do. And I suppose maybe that's what I meant. Like, that's the kind of the when you're given much more complicated functions than this, the trick can sometimes be just in the simplification. Like you can end up with lots of terms and everything, but in this case we've just got a 5. This is just going to simplify nicely. We've got a 5 up top, and we've just got our 2x plus 5 squared at the bottom.